So everybody has installed the Python on their laptop. So hey, can you tell me who the class has decided to make their representative? Okay, so let's start the lecture. Today is lecture number 2 on this course on computer programming. We talked about the elements of computer. We said that the computer has a CPU in it, it has a memory in it, it has storage devices in it, it has the input device, it has the output devices, and it has some communication devices like wireless card, LAN card, and router and things like that. And all those devices are connected via a bus. A bus is a connection. A bus is a collection of wires which takes the data from one component or one element to another element. Okay, so a bus is like a combination of wires which is used to transfer data from one element to another element. Now let's talk about bits and bytes. Now the computer uses bits and bytes to represent information. Okay, 1 and 0 is a single bit. So 1 represents 1 bit, 0 represents 1 bit. And a combination of 8 bits is called byte. This is one example of byte, and that is another example of byte. So byte is nothing but a combination of 8 bits. Okay, and multiple of bytes are used for large data, like your file is 10 kilobytes, 13.5 kilobytes, 60, your movie is 1.2 gigabytes, So you use a multiple of bytes to represent large data. So any questions in this byte and bits? Okay. Now let's talk about the memory in a very basic form. When I say memory, I mean RAM, okay? Remember that. And when I say storage device, I mean hard disk, USB, or solid state device. So let's talk about the memory at the moment. So what happens in a memory is that we have a chunks of spaces, and these are the spaces where we store data, and in this example the data is stored in the form of a byte. So we have one data here, one data here, one data here, and one data here. And these locations where we save the bytes as an address. So what we say is that this is the memory address for this location, and this is the memory content. Okay, so similarly here we have this as a memory location. So we have a big memory. So we go to the location 2004, and there we save 4100000011. So this is the content of a memory, and this is the address of a memory. It's just like a house, You have many houses in your street. So you have many houses in your street, and the content of the house are the people, and every house has an address. Let's say 23, 24, and so on and so forth. So memory is just like this, okay? So you go into the house, you go into the memory, and in the memory you have the contents, you have the people inside the memory. So here we have a same scenario. So that this is our memory addresses, and these are the contents in those memory locations. Is everybody clear about this? So this is really important to understand the memory content and the memory address. Nowadays we have a 64 bits system. Some old systems are 32 bits. What they mean by 64-bit system and 32-bit system is that the address is 32 bits and the address is 64 bits. So look at this address. If this is decimal, let's take this example. So this address in the binary form will be 0, 0, 0, and 0. So you can find the binary form. Okay, let me say it again. So at the moment, these days we have a 64-bit system. What I mean by that is that the address is of 64 bits. Okay, and we used to have 32-bit system in old PCs, but now it's 64-bit system, and we are expecting it to go up. What I mean by 32 and 64-bit system is that the memory address is 64 bits long in the case of 64-bit system, and the memory address is 32-bit long in the case of 32-bit system. Okay, any question in this? Okay, let me repeat it. Do you understand the concept of memory address and the memory content? Okay, now the question you're asking is, what do I mean by 32-bit system and what do I mean by a 64-bit system? Am I right? Okay, now look at this address. Okay, this is 2000 in decimal or in hexa. Normally the address of a memory is written like this, x 2000. Can you give me a second? Just give me 1 minute. I need to connect my device so I can write it properly. It's not very smooth at the moment. Yeah, give me 1 minute, please. It's not easy to write with mouse. Yeah, just give me 1 minute. Okay. 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 Just give me a second. Let me make something changes in my slide so I can answer your question in a proper manner. Okay. Okay, I have added this slide in the lecture notes to answer your question. Can you see the slide? Okay, now look at this. So this is a memory, and these are the contents of a memory, let's say 0101, okay? And this is the address of a memory location. So this is the address of this location, okay? So if you have a 32-bit system, now count these digits: 1, 2, 3, 4, 5, 6, 7, 8. This 0x at the start of address means that the 0x at the start of address means that whatever comes afterwards is in hexa. You know hex? Everybody's comfortable with the hex system? Like we have a binary system, we have a decimal system, we have a hex system. In binary we have 0, 1, in decimal we have 0, 1 to 9. In hex we have 0 till where? 9, then A, B, C, D, E, and F. Am I right? Everybody's comfortable with that? So first of all, tell me if you're all comfortable with binary, decimal, and hex. Okay, so whenever you have this 0x, it means that whatever follows are the hex digits. So look at this address. Let me write it down here again. It's 0x0000321004. So this is a hex, okay? So if I ask you guys to make a binary of this hex, what would be the binary of it? The binary of, okay, by the way, to represent the one digit in hex, how many binary do we need? To write 4 hex in binary, we need to use this. Why 4? Because, and to write this 0 in hex in binary, we have to use 4 binary. And to write this 0, we have to use 4, 1, 0. I don't have space here. Okay, so if you count the number of digits, the binary digits, it will be 4, 4, 4, 4, 4, 4, 4. It's going to be 32 bits. Am I right? So this is a 32-bit addressing, and the memory which has 32 bits addressing is called as 32-bit memory system. Whereas here, look at this. How many digits do we have? Look at it. We have a hex. We have a hex system here again, 0x. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 hex numbers, and every hex number can be represented by 4 binary digits multiplied by 4. So we have a 64-bit system. We need to have 64 bits to represent this hex number. Okay, that's the first thing. Yes, you can ask question anytime. You can ask question. Turn on a microphone and ask a question. Okay, hex for 32-bit, right? Hex for, okay, I think I should make it a bit clear to you guys. Let me use properly. Okay, let's do it properly. I think there are many questions in your mind. So we have a binary system which has 0 and 1, okay? And then we have the hex system. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have A, B, C, D, E, and F. Okay, everybody comfortable with this? These are all hex numbers. These are not binary numbers, they are hex numbers, okay? Any question in this? Okay. Now to represent this hex in binary form, okay, can you help me out in representing this hex in binary form? How can we represent this F hex in binary form? Yes, 1, 1, 1, 1. And how can we represent this A in binary form? 1, 0, 1, 0. Yes. And how can we represent this 0 hex in binary form? Yes. So look at this. If you have any number, any digit in hex, now listen carefully. So any digit in hex needs 4 bits. What are bits? These are the bits, okay? 4 bits to represent its binary form. Okay, do you all agree with this? So we need 4 bits to represent 1 hex. We need 4 bits to represent 1 hex. Everybody clear about that? No, Khalid, not 0 answer. 0 is not answer. Nasir is right. Hassan is right. But Khalid is not right. Khalid, we need to have 4 zeros here, okay? Because this is hex. So this is the first important thing that you need to understand. We need 4 binary digits to represent 1 hex digit. So normally it's written like this. A16 is 10102. Have you seen anything like this before? Are you all comfortable with this? Similarly, 016 is 0000 base 2. Are you guys all comfortable with this or not? So what is the question? So what I'm saying is this 0 in hex form can be written is same as 4 zeros in binary form. This A in hex form, is same as 1010 in binary form. Okay, any question? So the point to make is that 1 hex digit needs 4 binary digits. Okay, 1 represents 4 digits in binary. Yes, but that's what I'm trying to say, Khalid. Perfect. 1 digit in hex. How we know it is 0000 or 111? Okay. What do you mean? How do we know it is? Okay. Whenever someone says it's hex, they always write this. It means the 3 is hex. If they only write 3, then you have to ask the question if this 3 is hex or decimal. Okay. In the computer system, when you see 0xA30, it means this thing means that this number is hex. This is hex. This is hex. This is hex form. Okay. It means it is 1010 for A and it's 0011 for 3, and then we have this. So this thing is this thing. The 0x means whatever follows are the hex digits. Abdullah Faisal, you got the answer? Okay. So if somebody says 3 and he does not say if it's hex or decimal, you always take it as a decimal. But if somebody says 30x, then this 3 is hex. Okay. Then it's not 3. It's hex. It is 0011 in binary form. Okay. And if I say, what about this? What is this? Who will tell me what is this in binary? Yes, it is 4 zeros for this and 4 zeros for this. And how do I know 4 zeros? Because we have this thing which tells us that whatever follows is hex. There's no space, by the way, Al-Walid. There's no space between them. So I am putting space just to make it clear. It should actually be like this. Okay. I just put a space to make it clear for you guys. Otherwise, there's no space here. Okay. So everybody clear about this binary and hex concept? Any question in binary and hex? So if there's any confusion, you can ask me about the binary and the hex. And after that, we'll talk about the addresses. No question? Okay, so now what happens is, look at this. Now, let's say you're living in this street. This is your street. And here we have many houses. So if the address, oh my goodness. Okay. So this is your street and these are the house. So every house has an address. So this address, if it's in hex form, maybe it's like this. So let's say you're living in some society where you have the houses and the house are numbered like this. So can you tell me what is the house number for this in binary form? What is the house number for this in binary format? Yeah, it's gonna be 0, 0, 1, 1, and 0, 0, 1, 0. So this is the binary address for this house. Okay. And what about this? What is going to be the binary address for this house? It's going to be A is 10, so it's going to be 0, 2, 1, 2, 4, 1, 2, 4, 8, 1, 2, 4, 8, and then you have 0, 0, 1, 1. Yes. So this is your house address in binary form, and this is your house address in the hex form. And similarly, here we have the house address in 0 hex form, and here we have the house address in binary form. Now, the same case is for the memory. You know, the memory is nothing that you have a space available to fill. You can put your data here, and this location has an address. If this address is 8-bit, so we have, okay, by the way, how many bits do we need to represent this address? How many bits do we need to represent this address? 8 bits. No, 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And how many bits do we need to represent this address? 8 bits. So if you have an 8-bit system, then you have a memory like this. Okay. But if you have a 32-bit address, then how many hex numbers would there be? No, for 30, this is 4 bits. Yes, 8, yes. So the same case is here. Look at this. The same case is here now. Let me come to the files. Doctor, how I know hex 2 and 4? Let me come to the slide first, and then I'll take a question. Let me come to the slide first. Where is it? No, that's not the one. Yes, that's the one. So look at this. Here we have 8 hex to represent the address for this space. And here we have the 8-digit hex address to represent this space. And for 64-bit system, we have a 64-bit address. So in hex, how many hex digits would there be for 64 bits? How many hex digits do we need? We need 16. So look at this. We have 16 hex digits to represent the 64 bit. So this memory content has an address which is 64 bits long. And to come to this memory location, to get to the content here, you need to know the address first. So you come to this address and then you read from the memory content. Okay, is it clear? I will come to your question, Waleed, in a minute, but I need to know first thing, that is it clear? Like if you want to read about this content here, then you can only read the content once you ask your computer to go to this memory address and then read the content. So this is what we are going to do in the programming. We'll go to the memory address, read it, and then we display. Okay. So if you have, here we have the memory designed such that every location of a memory has a 64 bits of an address. 64 bits mean what? 16 hex digits address. And at this address, we have a location where some content is saved. Okay, now let me come to the questions one by one. Al-Waleed said, Doctor, how I know hex 2, 4, and 6, whatever you mean if somebody says 2, how would you know if it's hex or decimal? Am I right? Or if somebody says 4, well, he should put a 0x here. That means this 2 is hex now. Okay. So if somebody says 0x2, it means this 2 is hex. Can you turn on a microphone and explain me the question, Waleed, because I'm not understanding the point that you're trying to say. Okay, so you have the problem with the binary conversion, man. The 2 for hex we need 4 digits. This is 1, 2, 4, and 8. So you can write this 2 as 1, 0, 0, 0. Okay, you're asking that shall I write 2 like this, or 2 like this, or 2 like this? Am I right, Al-Waleed? Okay, my friend, look at this. This is very simple. You are at the moment you are dealing with the hex system. What if we have F here? How many digits do you need? You need 4 digits, okay, to represent F in binary form. So whenever you have a hex, you use 4 digits. You don't use this or this, okay? So whenever you have a hex system, like if I say 0x2, then you write this, okay? But if I only say 2, then you can write this. Write this in binary form. But if I say write the binary form for this, then you must write this, okay? Because when you have a hex system, you always use 4 binary digits, okay? Does it help, Waleed? Does it answer the question? But if it's only 2, then you can use 1, 0, okay? By the way, so hey, what is the question? What is that you don't understand? I did not get it. So hey, what is your question? Can you turn on microphone and help me out? Can you give another example? I think you should turn on a microphone now because, don't worry about your English.
Alaikum, Dr. Sam.
Walaikum assalam. Yes, please.
Doctor, I don't get the whole concept of between the two things. I don't get the relationship.
Relationship with what?
Between the binary and the hex. I don't get it. I don't get the whole thing. I've always had trouble understanding it.
Okay. By the way, do you understand how to convert binary into hex and hex into binary?
No, that's the problem.
Oh, okay. Well, what's your name, by the way?
Suhaib.
Suhaib. So let's go to the whiteboard then. Okay. Now we have a big problem here. Don't worry. We'll call it out, inshallah. So, okay. Sometimes simple things are very difficult to explain, but I'm gonna try it out. Right. Okay. First of all, let's just not talk about the reasons. We are not talking about the reasons. Why do we need it? Okay. We're talking about how it works. Okay. We're not talking about why. Why do we need this? Okay. Once we know how it works, then we talk about why do we need it. That's the first thing. So the thing is that how should I explain here? Let's say we have this. Oh my goodness. Okay, let's say we have this as a binary number. Okay, so what actually happens is, and if I ask you guys to write a decimal form for it, so what will you do is you start from here, from this side, and this first means 1, this means 2, that means 4, and that means 8. And if you have more things, then you have 1, 2, 4, 8, 2, 4, 8, 16, then you have 32, and so on and so forth. So at the moment, we only have 1, 0, 1, 1. So you simply add the numbers where you have 1 here. So we have 1 here, we have 1 here, 1 here, and 1 here. So if you add these 3 numbers, that gives you an answer of 11. So this is an 11 in decimal. Now let's take one more example. Let's say you have 1, 0, 0, 0, 0, and 1. So again, you write there 1, 2, 4, 8, 16, 32. And you must be thinking how I write this thing, This is nothing but this is 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. Okay? This is 2 power 5, this is 2 power 4, 2 power 3, 2 power 2, 2 power 1, and 2 power 0. So where do I have ones? I have ones here and here. So I simply add them, and this binary is equals to 48 in decimal. Does it help? So hey, I'm not talking about why do we need it. I'm just talking about how it works. Okay, why is a different story. So do you have an example in your mind that you would like me to solve? Give me one example that you would like me to solve. No example. Okay. Now the next question is, how could we write the hex for this? Well, there are multiple ways. Okay, there are multiple ways to write hex from the binary. Look at this. To write binary to hex, you make combination of 4, 4. So if I take this as an example and I want to write the hex for it, I'll make a group of 4. So I'll make a group of 4 and a group of 4 here. So I'll add 0 to 0 extra here. So what is this in decimal? This is 0 in decimal. And what is this in decimal? 3. So this is nothing but 0x30. This number, the blue number. So 1, 1, 1, 2, 3, 4. Binary is nothing but 0x30. Okay. Have you not covered these things in any earlier course? Is there any question? Any question in this? Similarly, if I want to write the hex for this, this is already a 4. So the decimal for this is 1, 2, 4, 8. It's going to be 11, 0, x, 1, 2, 4, 8. 8 to 10, 11. And 11 and hex is A, not A, B, 0xb. Okay, or you can write simple B16. Any question in this, guys? So hey, can you turn on microphone and tell me if there is still any confusion?
Yes, Mister, I'm really confused. I still don't get it. I don't know. I don't know what the ones and zeros represent. I don't know anything. So I know it's binary, but I can't understand it.
Okay, now let me come to the point again here. You know what? You're all double students, am I right? You're all electrical engineering students. No, no. Then what are you? Are you mechanical, civil, industrial? Yeah, freshman, but you can choose electrical engineering if you want to. Am I right? Yes, I know. You can choose later on if you want to go to the mechanical, electrical. So then you must have something in your mind that where you want to go to. Yes, yes, yes. So what happens is, let me tell you the story of one and zeros. I'm going to tell you the very basic story, okay? It's a very basic story. So it will work for you, but as you go into the master's and PhD level courses, then you will realize there's more things to it. So at this moment of time, what happens is that this memory is made up of transistors. Transistors are a small device. What they do is let's say we have the transistors here. Let's say there are the 3 transistors. Let's say we have the 4 transistors here. Okay. What happens is when you have a data, let's say a movie or any image, then all those things are converted in 1 and 0, then 1, 1, 1. And what I mean by that is that wherever we have 1, we have 5 volts, and where we have 0, we have 0 volts. This is 1, 0, 0, 1. Okay. So whenever the computer sees 5 volts, it understands that this is 1. And whenever the computer sees 0 volt, it understands this is 0. Okay. So what we do is, then we don't have to worry about the 5 volt and the 0 volt. All we are worried about is 1 and zeros. So whenever we have 1, we actually have a 5 volt on a transistor. And whenever we have a 0, we have a 0 volt on a transistor. And the memory is made up of a million and a billion transistors. So all those transistors hold some voltage. And that voltage, if it's 5 volt, we say it's 1. If it's 0 volt, we say it's 0 bit. And this combination of 5 volt and 0 volts make 1 0 1 0 0 0 1. And that combination of 1 0 zeros makes up a file that we want to see or we want to watch it. Is that your question, Suhaib? So 1 and zeros are just for ease, and this is the actual thing in circuits in the hardware. Okay, but we say that whenever I say 1, I mean 5 volts. Whenever I say 0, it means 0 volt. I don't have to repeat again volt, 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 volt. I just say 1 and zeros for the ease of explaining, or for the ease of understanding, for the ease of delivering. Is that your question, Suhaib? Yes. So what we do is we make a combination of 1 and zeros, which is a combination of 5 volt and 0 volts. In some systems, we don't have 5 volt, we have 3.3 volts. We have 3.3 volts for 1 and 0 volts for 0. We have different systems. We call them TTL systems or CMOS systems. So let's not go there at the moment. I'm just telling you that in many systems we use 3.3 volts to represent 1 and 0 volts represent 0. So we have many available systems, TTL systems, CMOS systems, and so on and so forth. That's not the point of the class. The point of the class is that you understand what do I mean by 1 and zeros. Okay? What it means is that you have 5 volts, 0 volts, 5 volts. So you have a series of transistors and they're holding some voltages. Okay? Okay, by the way, if you go into EE, you will learn more about it, how this hardware actually works. And that's a very interesting idea, you know, that's a very interesting concept. Yeah, whenever somebody say 1 and you're not sure if it's binary or hex, then you must ask the person first of all. Otherwise, if the person wants to say 1, you have to ask him. If it's 1 base 2, 1 base 10, 1 base 16, you have to ask him, okay? There's no way to tell. There's no way to tell if it's 1 binary or 1 hex. Okay, you have to ask him. One way is this. This is 1 hex now. Okay, Hassan? I mean, if I want to change between hex to binary, yeah, so first of all, you have to tell me. So let's say if you have 1 hex. To represent hex in binary, you need 4 digits. So you have this. Okay. So 1 hex digit takes 4 binary digits. Okay. By the way, we have discussed. I'm happy that we are doing this discussion, but we are far away from the detailed lecture. We'll cover it. So what about the others? What do you mean by others? Give me the example. Tell me. You know, 2 or 3. Yes. So I just told you we need 4 bits represent 1 hex state 0010. Okay. By the way, can you guys give me 20 minutes extra? Guys, can we do 20 minutes extra? Anybody has a class or any commitment? Oh no, Abdul Rahman is busy. Okay. Because you know I need to complete a few more topics today. Is it possible for you guys to find a slot for 20 minutes later in today or tomorrow maybe? Can you all find me a 20 minutes slot? Yes, I know you have class now, but can you find me any others? Sohaib, can you help us find us a 20-minute slot to complete the lecture because I have to give you assignment. Can we do 20 minutes lecture at any time? Tomorrow, tonight, anytime. Give me 20 minutes maybe, you know. Okay, let's complete this slide and then we talk about the flow chart later on. By the way, can you guys give me 20 minutes tonight or tomorrow morning, tomorrow night? So hey, please, yes. Can you help me with that? Tomorrow at what time? 20 minutes are enough for me. Yeah, can you all, Suhaib, can you coordinate with the students and Suhaib, can you first of all give me your WhatsApp number? I need to save WhatsApp number first of all. You are the CR, you are the class representative now. Suhaib, can you tell me your WhatsApp number so I can message you and we can take it out. So it's 0966. How many fives are there? 1, 2, 3, 5, 6. 5406. Okay, so hey, please, I will send you a message on the WhatsApp. So then you can tell me what time is good for us all to come for 20 minutes and complete this lecture. Yeah, but some people have classes. How many fives are there? 3 fives. Okay, but you're not on the WhatsApp, so hey. Oh, you are. Okay. So let's talk about this slide and then we conclude. Yes. So yes, Suhaib will talk to you guys and find 20 minutes slot and then we can.
Doctor, they want
Yes.
to take it now. They want you to.
Sorry.
They want you to continue now.
But there was someone who was saying that you cannot continue.
Yeah, the next class is at 3:30, so you still have time.
Okay, but I cannot see on the WhatsApp, by the way. Can you repeat your name? 00966 55?
You can put the national key +96 if it comes up.
Yes, 966 55 565 406.
55 555 66 54.
Oh, 66.
Yes,
66?
Yes.
And then you have 5. You know, it's really hard to read the number like 555, you know?
555 66 5406.
Okay, I got it. Okay, so we'll continue for 20 minutes. Anyone has a problem? You can say it now, please. Okay, so normally if you go into your file system, you say my file is 1 kilobyte. What actually you think kilo as 1000 bytes, but that's not the case. When I say kilobytes, you actually are saying 1024 bytes. Why? Because you're working in a decimal, you're working in a 2-power system. Okay. Similarly, when you say megabytes, you think of it as 1, 2, 3, 4, 5, 6 bytes. Well, that's not right. The right way is that this is a megabytes. Okay. This is not a big deal. All I want to say is that you always measure the size of a memory in 2 power. So your memory cannot be of 1000 bytes. It will always be of 1025, 1024 bytes. Okay, that's a objective of this slide. Okay, all right. So now that is what I was trying to teach you today, which is a flow chart. In the flow chart, we have we have discussed the flowchart in the last lecture as well. Let's just close this topic and by telling you more about it. So whenever you see a round rectangle, round rectangle has a round angle. What it means the start or the end of the flow. So look at this. At the start, we have the round rectangle. At the end, we have the round rectangle. So this is a symbol that is used to represent the start and the end of the flowchart. The square rectangle is used to represent the operation. Like if you have an operation here that 2 multiplied by a, you represent this operation in a square rectangle, okay? And the diamonds are used for selection. Like here we have a diamond. Diamond means if it's false, you go there. If it's true, you go there. It's like a option, the selection. You have 2 options here. And this parallelogram represents input and the outputs, okay? So let me do one example here. Let's try to draw the flowchart for this example. The question is, draw the flowchart of the area calculation of a circumference looking at the pseudocode. So this is my pseudocode, and if you have a circle with a radius of r, the area is going to be pi r square. Am I right? So the area of the circle is pi r square. Now we need to draw a flowchart for this pseudocode. Pseudocode means it's not really a code, but pseudo means kind of a code, okay? Kind of a code. So what's the first step? The first step is to declare A and R. What is A? A is area and R is a radius. So we need to declare first A and R, and then we have to enter the value of R, what your R is, and then we have to check if R is positive. If R is negative, we say it's an error. If R is positive, then we go ahead, okay? So if R is not positive, then you stop and go to step 6, okay? Otherwise, if R is positive, then you proceed. You go to the step 4. What is step 4? You multiply R with R and pi, you get an area, and the step 5 is to print the value of area, okay? So this is the pseudocode, and our objective is to draw the flowchart for it. So let's see. What's the first part? The first step is to declare A and R. So we are first use a round corner rectangle, okay, to represent begin. Remember that the round rectangle is used to represent the start and the end of the flowchart. So we use the round to represent the begin. And what is this? Here we are declaring that R and A are float. Forget about this word float here at the moment, but as we move along, we'll learn about the float. So we are declaring A and R. And what's this parallelogram? This means the user has to input something. Look at this. Parallelogram means what? It's input or output. So in this flowchart, the user has to enter R. And once we have R available, then we check if R is positive. If R is not positive, it's negative. If R is positive, we have to check. This is the step 3, okay? If not, then you go to step 6. If R is not positive, and what is step 6? Step 6 is end. So we declare that the error, that the radius must be positive, and then you go to the end, step 6. So this is step 3. This is step 2. This is step 1. But if R is positive, then what we do is we go to the next step, which is step 4, and then we go to step 5, and then go to the end. So this is the pseudocode, and this is the flowchart for this pseudocode. Everybody comfortable with this? So you should know how to draw this thing from this, and you should also know how to go from there to there and how to go from there to here to there. Let's take one more example. Here we have to make the flowchart to find the factorial. You know the factorial? N factorial is nothing but n times n minus 1 times n minus 2 times 3, 2, 1. Okay. Now this is the pseudocode that we have to use and draw the flowchart. What's the first thing? The first thing is that we have declared n and f as an integer, and then we initialize f to be 1, and then we enter the value of n, and so on and so forth, okay? So let's go to the flowchart and study it from there. So what's the first step? Declare n and f as integer variable. So we use begin, okay? And this is our n. Look at the symbols. It's rounded rectangle. So we declare n and f. So here we declare n and f as an integer. This is step number 1. By the way, whose mouse is this? Okay. And then we initialize f to be 1. Step number 2, we have initialize f to be 1. And then we check whether n, yes. And then we check if this n is positive or not. So we input this n. This is step 3, sorry. So the next step is to step 3, which is enter the value of n. And then the step 4 is this, that we check if n is positive or not. If n is not positive, then what do we do? If not positive, then make f1 and go to step 8. Then make f1 and go to step 8. What is step 8? Print the value of f. Okay? Everybody clear about that? So this complete is step 4. And if n is positive, then what do? We go to next step. Next step is what? f times n. Then you find f times n. Okay, and what I'm saying is that you enter the value of n in step 3. So this is your step 3. You enter the value of n, and then you check whether n is positive. So you check n is positive. If positive, then you proceed to step 5. So if n is positive, yes, then you go to step 5. What is step 5? You go to step 5, which is f times n. But if not, if n is not positive, then you make f1 and go to 8. If n is not positive, you go to f1 and then you go to step 8. Okay, and once you go to step 5, you find this, and then you go to step 6, decrease the value of n by 1. So step 6 is this, that you decrease the value of, look at this rectangle. Why rectangle? Because this is an operation here. This is an operation here. That's why we have a square rectangle. So step 6 is to reduce the value of n by 1. And what's the step 7? Continue, go to step 8 if n is 0. Then you check if your n is 0. If n is 0, yes, then you go to step 8. If n is not 0, if n is not equal to 0, then you go to 5. Go to 5 if n is not 0. So if n is not 0, then you go back to 5. Okay? And at the end, you just say, once you print it, then you say n. So this is the flowchart concept. Any question in this? The Python will come in the next class. Okay, we need to first of all understand this concept of flowchart. Is there any question in the flowchart? So you have this pseudocode and you have this flowchart. You know, it's very important to understand how to write pseudocode. It's very important to understand how to write the flowchart. Any question here? So now you have this as your assignment number 1. So you have 2 questions in your assignment. You have to submit the assignment before Monday. I told you guys I will not tell you when is the due date. You have to submit the assignment before the next class, and you will submit the assignment on the blackboard. I have created a link over there. So in the first question, you have to draw you have this pseudocode and you need to draw the flowchart. And in the question number 2, you have the flowchart and you need to write me the pseudocode of it. So provide a pseudocode for this flowchart. Okay. We have 2 questions in assignment number 1. No, just on the paper. On the paper. Okay. So any questions? Yes, draw it on the paper. Look at this with your pen and page. But make sure you use the proper rectangle, proper parallelogram, proper round rectangle wherever it is required. So this is the key here. Use them properly. Okay. So yes, that's all from my side. If you have any question, you can ask me. It's already uploaded. It's already it's already there since last night. Question 2. This is question 2. Okay. Thank you very much.